All right, welcome back, everyone. This video is actually more of a continuation on my previous video where I discussed the viability of my very old 65-year-old forced hot air oil furnace. A lot of stuff I want to talk about in this one, but my battery might kick out on me before I'm done finished talking, so hey, it is what it is. So this is more of a response to a lot of the questions and comments and suggestions that I received from my viewers. So if you left a comment on my previous video, this is for you. Maybe I can help clarify a couple of points of discussion. Number one, first and foremost, when it comes to determining what fuel source will heat your home, you have to take into consideration your region, your local infrastructure, and personal preference. So there are three primary heating fuels that are used in the United States. Actually four when you factor in electricity, which is used for heat pumps and electric heat. Electric heat is, we're going to just get that one out of the way for a sec. Electric heat and heat pumps are very common and popular in warmer climates. I'm in the northeast of the U.S. Heat pumps do exist up here, but they're not often used as a primary heat source. If a home has one equipped, or is equipped with one, it's more of a backup. Because they don't work very well in some of the coldest winter weather that we get up here. So we're going to knock that off the table right off the bat. No heat pumps up here. In fact, if I called someone and had them install a heat pump, they'd probably laugh in my face. So we're not going to do that. The other one is electricity. Electric heat is common in warmer climates, in areas where heat is not something that is, needed as often as it is up here. Electric heat actually was really big up here back in the 70s when the electric company was pushing for a lower rate for certain heating and cooking applications. But that did not last very long. People quickly abandoned electric heat, and now it's in the rearview mirror. That leaves two potential sources of heat. That's liquid propane. Actually, three, because we got five. No, three, four. Anyway, we got liquid propane gas, natural gas, and oil. Those are the three amigos that are very common in this state. However, natural gas, which is the most obvious choice that everyone seems to be telling me I need to install, that is not an option in much of my state. In fact, it's only available in few and far between neighborhoods. So natural gas is no bueno. Can't do it. I actually did ask about natural gas in this neighborhood when I bought the house. I contacted National Grid, who services the few locations in the state that offer it. And they said, not in your lifetime. So no natural gas, can't be done. So that leaves oil and propane. Propane, or LP gas, is the same stuff that you fire up your grill with on a nice warm summer day, or as I do year-round. Liquid propane is a great fuel for heating your home. It is expensive. It is not as cheap as natural gas because they actually have to load it into a truck and they deliver it and pump it into you. You have to buy new tanks. In this case, I'd have to get rid of my oil tank and install two large propane tanks. They're like 100, 200 gallon tanks, and they go outside the home because you can't have them legally inside your house. So here's the problem with that, and this is why I'm not doing LP gas. Because I would have to level off a section of my yard. I would have to rent a machine or hire someone to level off the yard. I'd have to have a concrete slab poured per building code requirements. I would have to purchase the two tanks, and then I would have to have them filled. We're talking thousands of dollars here. and I'm not made of money. So thousands of dollars just for the tanks, and then I got to fill them all up. I mean, seriously, guys. And I can't install them. I have to hire someone to install them, and people don't work for free. Then I have to buy, obviously I need a furnace anyway. I'd have to buy a new furnace. And we're looking at, Christ, I think one quote I got to, because I actually did look into this. I was looking at somewhere around $10,000 or so to have this all done properly, to code, with permits pulled and all that happy shit. So about 10 grand, just so I can have heat again. Now, and that was before I bought the new oil tank. So let's look at that for a sec. So when I bought this house, I was forced into buying a new oil tank. I was going to put in a whole new system, but I just, after determining that this unit was good and usable for at least one summer or one winter, I actually had a few people come in for quotes, quoting out a whole new system, and a new tank and all that stuff. And what I ended up doing was I decided to keep the furnace for one winter, replace the oil tank for now, just to get the house occupiable. And that cost me nearly $2,000. And yes, I got multiple quotes. It's expensive, and because of the area that I live in, you cannot install an oil tank without a permit, without licenses and all that. So that's just how it is, man. That's just how it is. So I had to pay for the tank, fill it up. That was, Jesus Christ. I think I spent, because I had to fill it from empty, The original tank was unsafe. Nobody would fill it for me. And that's the situation I was in. Okay. So now I think you have a better understanding of why I'm sticking with oil. Now let's talk about the operating costs of oil. Now oil is... it depends on the market conditions, but generally oil and liquid propane are like this. So they kind of intersect with each other, One's high, one is low, the other one's, they're back and forth. I don't know where we're at right now. But one benefit of oil is that you get more BTUs per liter or per gallon of oil than you do for a gallon of liquid propane. So oil produces hotter heat. A lot of people describe it as a warmer heat, or a more bone-soothing heat than propane. There's another factor that needs to be considered as well, and that is the service life of the heating unit. Now, this is ridiculous. This thing lasted 65 freaking years, and could probably go another 65 more if I just doctored it here and there, and we'll get into that in a minute. I'll clarify what is actually wrong with it in a sec. But a brand new, this is based on, I've read forum posts. I've been doing a lot of research for the past couple of months on which ones last longer than the others. And this is what I've determined. And I'm no professional here, and I have only spoken to a few technicians, but oil furnaces, I believe they cost a little bit more than a propane furnace, but they last longer on average, because the heat exchangers are much thicker steel. Because oil produces more BTUs per gallon than propane, the innards of the furnace are a little bit beefier, and therefore less prone to cracking and less prone to thermal stresses than an LP fired unit. So I might get an additional 5 to 10 years out of an oil furnace than I would out of a propane furnace. And I'm going to spend a little bit more because oil furnaces are more complex. They're heavier. The installation costs are about the same either way. So basically that's what I'm looking at right now. At this point in time, from where I'm standing, from what I have budgeted for this job, oil is the way to go. Now, if I were building a brand new house right now, what do you think I'd put in? Of course, liquid propane. But I would buy a good quality, expensive propane furnace, one of the Cadillac models, whichever one has the highest rated or the best warranty on the heat exchanger. Now the furnace that I'm buying is a Rheem. I think I'm going to do the ROLA. I forget which exact model it was, but I've done my own. I've done my own homework. I've looked at all their product offerings. I've looked at options. Before I go to the dealer, I'm educating myself on what I'm buying. I already know what I'm buying. I'm going to tell them what to install rather than them tell me. Now, of course, don't take that literally. If they suggest something different for a reason that is legitimate, then I'll go with what they suggest. But my plan is to stick with a Rheem furnace, which I've heard great things about them. I haven't heard a lot of bad things about Rheem. I do know that their natural gas and liquid propane gas-fired units are known for heat exchanger cracks after about the 10 to 15 year mark. But that is also true for some other products, such as, I believe, Amana and Goodman furnaces. So, you know. The good thing about the oil furnaces is they do advertise the thickness of their heat exchangers. So the Rheem heat exchangers are, the primary is 10 gauge, the secondary is 14 gauge, and one of the best furnaces on the market today on the oil heat side is the Thermopride units, which have a 13 gauge primary and secondary, I believe. So the Thermopride furnaces were going to cost me about $1,000 to $2,000 more. So I'm going to go with a Rheem. Okay, so we've addressed that factor. What's going in, why I'm choosing it. I don't think I need to clarify myself anymore. No natural gas, no heat pumps. I need something that's going to last and produce a good solid amount of heat for a good amount of, for the life of the unit. I grew up with oil furnaces. I've only had gas heat in maybe 2 homes that I've ever lived in my life. Seriously. And all of the oil furnaces that I've had in the homes that I've lived in growing up, my parents' houses, relatives, those oil furnaces have been usually over 20 years old on average. My parents' oil furnace, theirs is 30 years old. It was installed in 1990. We lived in a mobile home that had a Miller furnace. If you know what if you're familiar with mobile homes, Miller is that's the name brand that they all use. That thing was 18 years old when he moved in, and it was about 25 years old when he moved out. So 26 years old actually. It was we lived there a while. So oil furnaces in my from where I'm sitting, from my experiences, they have been very reliable. They do require maintenance. Now let's get into that. What kind of maintenance do you do on an oil furnace? It's actually not that much. Probably a little bit different from a gas furnace. On an oil furnace, you want to keep the heat exchanger cleaned out. You want to have someone come in and they use these metal rods that have barbs on them, I believe. And what those do is, and take a look at this. We didn't see this in the other video, but we're going to see it now. Let's take a look in here. This is the exhaust side of my heat exchanger. Now, what you're supposed to do is you're supposed to use a combination, I believe, of wire brushes and steel rods, and you're supposed to clean all that crap out of there every year or every 2 years. This one hasn't been cleaned in, we're talking decades, probably 20, 30 years. And look at all that. That is awful. That is like the worst. I just can't believe how bad this is. I mean, this stuff is coming off in sheets. It's nasty. And what is it? It's rust, it's magnetic, or it's ferrous. It's rust, it's combustion byproducts. Some of it could actually be the original coating on the inside of the heat exchanger now flaking off. So that's pretty disgusting. And that is why this furnace has been running so poorly. It's over-temping. I think I said that in the previous video. What's happening is it's reaching its high limit for the plenum plenum thermostat that's right in this region here. And what it's doing is it's cutting off the burner because it's reaching over 225 degrees Fahrenheit. And it keeps happening. Every heat cycle it happens. And that's because there's just not enough throughput, not enough airflow from the combustion chamber on out to the exhaust, and this is why. Now, a modern furnace would never last this long. The heat exchanger would have failed long ago. This one, on the other hand, is still good. I don't see any signs of any leakage. I actually looked all over this thing on both ends of it. I cannot find any signs of any leaks anywhere. There's no rust holes, there's no cracks, there's no heavy corrosion, nothing that would say, yeah, it's junk. The reason that we're condemning this furnace and replacing it in its 65th year of operation is actually as a result of a failing combustion chamber. And I'm trying to seal it up best I can. The combustion chamber is lined with fire brick, but not ceramic fire brick. It's asbestos fire brick. I only know this because I had one piece that fell out in chunks, and I didn't know what it was. And I picked it up, and I'm like, this doesn't weigh as much as brick. And I'm looking it over, I'm like, oh shit. It's cast asbestos cement. It doesn't weigh a lot, but it's fireproof. And it, yeah, so there you go. It's all completely lined with asbestos. Now, I am not going to subject anyone, let alone myself, to having to pull all that apart and then have, new bricks cut and placed into position. Not going to happen. So anyway, so that is the situation. I'm not rebuilding that combustion chamber. So what I'm going to do is I'm actually in the process of hiring someone to replace this unit. I already gave him the specs of what I want, and I've asked him to send me a quote, and we're going to go from there. He's going to get a lot of scrap metal out of me. This furnace weighs more than a car, so there's a lot of good scrap steel here. Hopefully, I mean, they do expect, I believe, an older unit like this to have some hazardous materials, which I'm sure they factor that into the job. They know what they're doing. I'm not an HVAC guy, so I don't know what that all entails, but what I do know is that this thing is going to be hauled away. Now that's what we can see. What we can see is that at least the combustion chamber. Now, a modern oil furnace uses a refractory. They call it a refractory combustion chamber. It's a solid, it's like a hollow. You just Google it. It's a unit that kind of sits inside there. It's made out of I don't even know what the material is called, but this is basically what they're made of. This is a different form of it. This is a flexible sheet made for cutting custom gaskets out of. I actually got this for an old oil gas furnace that I had in my old condo. And this stuff here is expensive, but they make the combustion chambers out of this stuff, and it's very fragile, and it just kind of sets in there. And usually they last, but if you manhandle it, it'll break. But these use either brick or asbestos blocks or something like that. Where was I going with this? So long story short, we're gonna have this thing replaced with a new ream, and I'm waiting for an official quote on that one. I'm not going to be retaining the humidifier option. I'm going to be removing them. I'm going to take that out myself. That's missing half the parts that are in there, that are supposed to be in there. That's an old, what is that thing? Flare Weather Atomizing Humidifier by Flare Manufacturing. That's go bye-bye. But all they're going to be doing is they're going to probably remake the exchanges here, what's the term I'm looking for? The transitions. These need to be probably remade for a new furnace. The new one will be on blocks because that's just how you install them. This one is it's directly on the concrete slab, which it shouldn't be. And as a result of how it's sitting, now there's another factor that we hadn't really discussed. We do not know the condition of the bottom of the entire combustion chamber, which is made out of steel, because we can't see it. But I hazard a guess that when this thing gets picked up off the ground, it may fall apart. It's almost impossible to tell at this point, but we could have some serious structural damage to the unit itself as a result of water pouring around it for so many years. I'm going to be fixing that. Now, I'm actually holding off on fixing my door until this is replaced, because I don't want a new door getting ruined by people moving equipment in and out of the house. So when this is done, I'm going to start immediately by rebuilding that door frame so it's watertight. Now, I've already started some of the prep work. I've rerun the electrical feed from the panel to this unit. This is 14-2. Oil furnaces require a 20 amp circuit. So what I've done is I've wired it again for a 20 amp. Did I say 20 amp? I meant 15. Oil furnaces require a 15 amp circuit, so that's why I've used 14-2. I had to rerun the line because of the lack of any grounding. So I took out the old ungrounded wire, put in a grounded wire, and I'm going to pull this 20 amp breaker that they put in. This should be a 15. In fact, a lot of these need to be replaced with 15s to be compliant with any reasonable code enforcement. But it looks like they just loaded the panel with 20 amp breakers. That's not the right way to do it. They're oversized for the wire and the application. So I've been running 20 amp circuits, all these yellow ones I did, and I've been putting in 20 amp breakers, but everything else should be 15 amp. I'm not too happy about that. So we'll be replacing the breaker with a 15, and that's what we're going to do. So now another thing I want to talk about is the stack switch. Now, this was brought up by another viewer of mine in the last video, and he was talking about how dangerous stack switches are, and I want to kind of point that out because that was one of the factors that I took into consideration when I really decided to just rip the damn thing out. So let's talk a little bit about the stack switch and what it does and why it's so dangerous of a design. So on a modern furnace, an oil furnace, even a gas furnace, there's some sort of control module, and what that's going to do is it's going to determine what power state the burner should be in, and it'll also trip it or lock it out in the event of a malfunction. So what's going to happen is when the thermostat calls for heat, it's going to apply power to, in this case, on an oil burner, there's two main power draws. You've got the motor that drives the oil pump and the draft blower, which we have. Where is my blower? Here's the motor. Now this is the draft blower. Now this forces air into the combustion chamber. It applies power to this device. This is a transformer, 10,000 volt transformer. That supplies power to the electrodes, which creates a spark, a continuous spark. And with that rotating blower, the rotating oil pump, which is pumping oil through the nozzle into the combustion chamber, and the ignition source, the spark, you should have instantaneous ignition. Now, a modern furnace is going to give it a very short window to successfully ignite the fuel. And it's going to detect that ignition using an electronic eye. And the electronic eye produces a low voltage, a fairly low amount of power. I believe it's a photoelectric eye. What it's going to do is it's going to create a small amount of power that will trigger some mechanism inside the control module that tells it that ignition has succeeded, carry on. Now, on an older furnace, like this 1950s beast from hell, it has a slightly more crude and a very analog approach to detecting a successful ignition. The problem with this device is that it takes a lot longer for it to determine whether ignition has succeeded or failed. Let's take a good look at this device. This is called the stack switch, and these are very common on furnaces made, I believe, prior to the mid-1960s, or at least prior to the 1970s. And they have been known over the years to cause significant property damage, house fires, and all that great stuff. Because when things go right, all's well in the world. But when things go wrong, they can go wrong in a very bad way. So this probe here is actually inserted into this section, this elbow piece in this case, of the exhaust. Now what this is doing is it's looking for heat. But due to the sheer analog and very simple nature of this device, it can take quite a while for it to detect the amount of heat needed to make a determination of a successful ignition or a failure. What do I mean by that? Well, it's using a good old-fashioned bimetallic strip of metal. And what happens is when you have, of course, two dissimilar metals laminated together, I think it's copper and tin, copper and some other metal. What happens is they expand at different rates. We all know that metal expands, but the two metals expand at different rates, causing it to curve, or in the case of a bimetallic coil, it's going to rotate. That is how analog thermometers work, believe it or not. Anyway, same principle, but in this case, that bimetallic strip expands, and it forces this rod to go into the box. Now, I just demonstrated this on another video with a torch, and I lost the footage, so I can't really show you. But what it's going to do is it's going to actually, this is so analog, but what it's going to do is it's going to push against these reed switches here. Can you see that? Let's try to zoom in a little better. You've got one, I can't even get a good look at it myself because I can get shadows here. You got 1, 2, at least maybe 3 switches going on here. Okay? Okay, so what it does is when the thermostat is calling for heat, it's telling this box, hey, fire me up. And so what this box is doing is it's taking the input signal from the thermostat, and on the startup sequence, it's going to be closing both of these two relays. That's going to supply power to the two AC circuits going into the burner itself. One of those circuits powers the oil pump and the blower motor, which is a draft blower. The other circuit provides power to the ignition system, the transformer that we just looked at. Now it says, okay, you can both run, I'll give you 20 seconds. If within 20 seconds this switch doesn't close or open or whatever the hell it's doing from the force of this bimetallic strip here, we've got a problem, and I'm going to shut you down. I'm going to shut both of these relays off. Now, that will happen if this doesn't move at all. If it doesn't heat up, doesn't ignite, doesn't produce hot exhaust gas, it gives it that 20-second window or whatever the number is. I don't know what it is. And if it doesn't succeed, boom, it trips this red button. And the only thing the homeowner is going to know is that, number one, it's cold, and number two, this button's sticking out. And therein lies the problem. So what that homeowner is going to do is they're going to come down the stairs, and they're going to press the button. Then it's going to, once again, all right, let's try it again. So it tries to fire it up again. Closes both relays, puts power to the motor and the ignition, and it once again tries to fire. Sounds all sweet and innocent, but what if it fails again? And the homeowner comes down the stairs and tries a third time, and it still fails. Well, that's when you get to the dangerous aspect of this device. What's going to happen is, if at some point, there and after, what you've got here, so let's just backtrack a bit. What you have here now is a potentially dangerous situation where the combustion chamber is loading, it's loading up with unburned oil. And when that unburned oil ignites, it can ignite violently. I know this because I've seen it happen when I was a child. I was probably 8 years old, and my father kept hitting the reset button on the furnace, and we had to leave the house because now we were in a mobile home. Now the furnace on a mobile home is on the living level of the home. It's actually, in this case, it was in the hallway, a very narrow hallway, and it lit off, and we had a combustion chamber full of oil, and it was booming and thundering, and the walls were shaking, and I was terrified. Now, that's a very small furnace. That's like probably a 50,000 BTU furnace. We're talking about a 100,000 BTU behemoth here. Imagine that combustion chamber filling up with oil. Yeah, and that is why these are bad. So, now, the thing is, the real danger in these, I believe, and I'm no professional, is that they allow too much time for a failed ignition to be determined. Whereas a photoelectric eye is going to happen very quickly. So it reduces the likelihood of a burner becoming, or a combustion chamber being full of oil. So, anyway, these devices, I mean, yes, they do serve a purpose, and yes, they do work, but they are totally obsolete. But they're still making these for units like this one. So if this had gone bad, I can still buy this. This unit is only about 10 or 15 years old. It's been replaced once or twice so far. But anyway, let's say it ignites correctly. Everything's working fine. We don't have a dangerous situation. It's a normal day in paradise. What's going to happen is, as soon as this thing starts to warm up and this coil starts to do its thing, or this metal strip, it's going to shut off one of these two relays, and that's going to be the ignition relay. Because on an oil furnace, once you have ignition, you no longer need an ignition source because it self-ignites. It just feeds oil into a flame. Now, where this can also benefit is if, for example, it successfully lights off and for some reason you lose the flame. I don't think that would happen very often, but if it were to happen, you would potentially have, you could have a situation where oil is still spraying in there and for whatever reason it went out. I don't know why that would have happened. If that's to happen, that's a damn good question. What would this thing do? Because it would begin to, it's still calling for heat, right? So it's still calling for heat. The thermostat's never said, hey, I'm done, shut off. But that bimetallic spring is cooling off. So what's going to happen is, it's going to, at some point, what will eventually happen is, at some point, it's going to call for ignition again. Pump is still running, flame is out, it's been pumping oil in the combustion chamber for God knows how long. And that, I think, is a dangerous situation. Could it happen? Potentially. If this unit were to malfunction, all kinds of cool stuff could happen. But the long and short of it is, these units aren't precise enough, they're not up to modern standards in terms of safety, and they're just bad news bears. So, once again, one of the final nails in the coffin is that I want a safer ignition system. I want a safer control module. I want a more efficient furnace. I want to save money on oil. One of my commenters mentioned that this thing is probably running at somewhere around 60% efficiency, but we have no data to base that off of. I never did do a combustion test. I should have done that. I should have had the guys come down and do a combustion test before I started dismantling it. But I didn't start dismantling this unit with the expectation of having to replace it. I want to drive that point home too. My plan was to put new igniters, new nozzle, and be done with it. I did mention in this video that oil furnaces do require maintenance. And the maintenance, I mean, it might have been this is like my 8th time filming this, so I could have missed this point altogether. But maintaining an oil furnace is critical absolutely critical, more so than even a gas furnace, I believe, for continued safe, efficient operation. And what you have to do in an oil furnace is you have to make sure that that heat exchanger is kept clean. And as I showed you guys earlier, it is not clean. It is really, really clogged, and that's not good. That's not good. That's really bad. That's probably been decades since its last cleaning. So you want to make sure the combustion chamber and the heat exchanger are clean and free of debris. You want to make sure that the nozzle is changed on at least a yearly basis, and the igniters or the electrodes are replaced on a regular yearly basis as well. It's kind of an annual maintenance. You want to make sure that the filters are changed. You've got a filter here. You've got a filter in the pump. I actually have that here somewhere. I am going to reassemble this thing here. I'm going to put it all back together again, just for funsies. And but yeah, you want to make sure that all that stuff is maintained and cleaned and working, because if not, you're going to have a short and very miserable life with your furnace, because they're a complex machine. They require specific, air-fuel ratios. They require clean, instantaneous ignition. They require the ability for the exhaust gases to cleanly pass through the heat exchanger and out the exhaust. You don't want that hot exhaust gases in there any longer than they need to be. Otherwise, you're going to have a situation like I have where it keeps tripping out. So in addition to that control module, you also have, or the stack switch assembly, you also have another switch, which is your air plenum thermo switch. And what that does, that's adjustable, and that has, I believe, 3 stops on it. What that's doing is that's controlling your blower motor, and that runs independently of everything else. That controls the blower motor power, and it also provides an additional safety cutoff. If, for example, the limit switch is reached, or the limit is reached on the plenum air temperature, what's going to happen at that point is it's going to tell that device, it's going to cut power to your gun completely. So it's shutting off power to that thing, and what it's going to do is allow the blower to continue running until the safe temperature is reached. Once that is reached and it's no longer at limit, power is restored to that box over there. The gun fires up and the cycle starts all over again. And then within a minute or two, thermostat's going to say, "Okay, I'm done." It's going to shut the whole thing down until the next call for heat. It's a pretty well orchestrated dance between components and how it all communicates. A modern furnace works basically the same way, but the technology is a little bit more refined. You've got a more safe control system. You've got optical sensors rather than old-fashioned bimetallic springs determining what's going on. And that's pretty much it. That's where we're going to end this series. The next time we do a video, I believe this will be out of here. I'll have a new furnace in, and we'll be talking about how that one works. I'm thinking about scavenging some parts off of this before the Reaper comes to pick it up. I think I'm going to keep that blower. I just know there's something I can use that for. I just know it. That is the original blower to this furnace. It's got new bearings. The bearings were done before I bought the house. It's got a new motor. It's got a new belt. And it runs. It sounds great. There's no weird noises. I did oil the bearings a while back, but I'm going to pull that thing out. That's a nice blower. That really is. It's something special right there. Worth salvaging, I think. I could probably use it in the garage or something. I don't know. Use it as maybe rig up some kind of like a fan. We can blow across the yard on a hot day. I don't know. I just like it. I don't want to get rid of that. But yeah, I'm a little surprised to see that the heat exchanger is in such great condition. It doesn't really show any signs of failure. It's got life left in it, man. So what we're going to do is, I think they're, like I mentioned this in this particular iteration of my video, but the transitions may have to be rebuilt, replaced, or redone. Humidifiers coming out. I'm going to keep the basement register installed. Maybe I'll put in a new one. But we're going to have a basement register just in case we decide to heat the basement. I'm going to see how the new furnace operates and how the cost of heat is looking on the new unit. Because I might actually, you know, crack that open and heat the basement too. Because the basement, you know, it once I get these windows replaced, I'm going to want to heat this space because it'll make the floors a little bit nice and warmer, I think. But I got to cut off this line here. That's a saddle valve. That's got to come off. I'm going to have to do something about that because saddle valves, you punch a hole in the pipe to install, and that's how they go on. And that one's just an accident waiting to happen. So, anywho, that's all for now. Thank you all for watching. And like I said, those comments that you guys left, that's why I'm making this video, because I feel that I need to better explain my situation. Remember, just because you're in one area of the world and you don't know what heat, you don't know about oil heater, does not mean what you have is better for me than what I have. Because if you live in the desert, and I would not recommend you get an oil or LP gas heat if you're in the desert. You might be better off with electric heat or a heat pump. But in good old New England, we take winter seriously. We need equipment that produces a lot of heat for the least amount of money possible. And right now, oil is that solution for me. That's the reality of the world. Every situation is different. Every region is different. I watch a lot of videos, of people in Europe, and their houses are set up completely different. And I'm looking at the way their houses are configured, and I'm like, well, that's stupid. Why is that over there? Why are they using that? Why aren't they using this? There's a reason for it, and that's why I'm making this video. So, to help clarify that New England's heating situation is a little bit different than that of a Nebraskan prairie dweller. So, all right, and that's it for now. Thank you for watching. So I decided to conclude this particular video, I would reassemble the burner, and we can take a look at the styling and talk a little bit about it. So, so this is it. This is the original burner. This is a quiet heat Model A. And I got to tell you, it's one of the most beautiful pieces of machinery I've ever laid my eyes on. And I mean, just look at it. It's very Art Deco. Now, this was built in 1954. That was the very end of this particular style oil burner. And after that, they went to the more compact packaged burners that you see on a modern furnace. The Beckett's, the Waynes, Carlins, and less so the Riellos, which are a little bit more elaborate, a little more modern styled. But this unit was designed for two purposes. It was designed to be used in a new install like mine when it was put in. But they're also used as conversion burners, and that's why they were designed to be mounted in basically any configuration. You've got this stand that can be removed if needed, or adjusted up or down based on the height of the firebox. But a unit like this would often be found inside a conversion setup where you have what was once a coal-fired furnace that was converted to gas or oil. And that is why these are so over-styled, because in a setup like that, it would be in the basement, in the living space, or in the trafficked part of the basement where the furnace would be. And it would be visible to the consumer, the homeowner. So they were really well styled and very beautiful when they're new. Even when they're 65 years old. So my hope is that somebody will want this unit. I am not throwing this away. You know, if the gentleman who sells me the new furnace doesn't want this for his own shop to display or clean up or even make it run again, I will keep it, and I will find somebody who will appreciate it, because it's just a beautiful piece and a part of history. You know, these are the units that heated the homes of the post-war home building craze. You know, a unit like this would have been installed, you know, in one of those post-war houses like this one. You know, these are the units that kept the baby boomers warm when they were children. You know, these were just a very, I think I'm missing a screw. I'm losing my voice. My allergies are really, really killing me right now, I'm telling you. But anyway, you know, these units were part of that post-war housing revolution that took place in the United States, at least. And there aren't really many left. And this may be one of the last of its kind in operation. You know, it was taken out of service a couple weeks ago. And so, with that in mind, I'd rather see it be appreciated rather than scrapped. There's really not a lot of value here in scrap metal. I think I don't even think this is cast iron. I think it's aluminum. And I just don't want to see it get destroyed. But let's take a look at how many parts have actually survived the test of time. It's not as many as you think. Most of this is replacement parts. This is our transformer. That is a replacement. You can tell because the tag says Sid Harvey on it, and Sid Harvey is a supplier of replacement parts for heating systems, air conditioning systems, etc. This motor I installed, this was replaced once before that I know of, and possibly once before that. So this is probably the third or fourth motor that's been on this. This is modern, doesn't look like it belongs here. My plan was to paint it green to match, but I never got to that point. This Sunstrom pump is a replacement, actually identified by one of my viewers. And further than that, this Firomatic valve has been replaced at least once or twice. The igniters, the nozzle, those are maintenance items. Those have been replaced. The coupler has been replaced between the pump and the motor and the fan. On the furnace itself, the control box and the temperature control unit, the limit switch, have all been replaced at least once. Inside the motor, the blower box itself, the motor and the shaft bearings have been replaced at least once or twice. Actually, I think more than once, because I found another motor stuck over there somewhere that was part of this furnace. It was the original, or previous replacement, blower motor. So I still have that. I mean, not much is original, but, you know, at least the chassis is original. It's almost like one of those hammers, you know. This hammer is 200 years old. The handle's been replaced 3 times and the head's been replaced twice, you know. So how much of it is really original? Anyway, my only mistake here was I ruined the oil line that goes from here to here, but that could be remade very, very easily. So anyway, so that's it for now. We're going to conclude the video, and I'm going to get to sleep. It's 1 in the morning, and I'm tired as hell. So have a great night.